All right. Welcome to the last Wednesday in August, everyone. As the summer starts to wind down and kiddos head back to school, if they haven't already, maybe you've got time to squeeze in one more short vacation. But you want to stay safe, so what do? Well, since it's National Park Service Day, might I suggest one of our wonderful national or state parks? And if you already visited one earlier this year, good on you. Now, why am I talking about parks and nature? Because that's a good segue into today's topic, optimizing nature in buildings with environmental surfing. For instance, catching a wave to surf is a great example of how nature can be leveraged to do most of the work for an intended purpose, like provide natural comfort in buildings. But with all this talk about surfing, does that mean I'm going to be introducing the Beach Boys or summon the ghost of Dick Dale? No. But I am going to introduce Vivian Loftness, who is a university professor and the Paul Mellon Chair in Architecture at Carnegie Mellon University. She's an internationally renowned researcher, author, and educator, having spent over 40 years focusing on environmental design and sustainability, advanced building systems integration, climate and regionalism in architecture, and design for performance in the workplace of the future, for productivity, health, and the triple bottom line. She has served on over 25 board of directors, including USGBC, International Living Future Institute, and AIA's boards, as well as on 15 National Academy of Science panels on sustainable built environments. Vivian has been recognized as one of 13 stars of building science by the Building Research Establishment in the UK, holds a National Educator Honor Award from the American Institute of Architecture students, and a Sacred Tree Award from the U.S. Green Building Council. She has a Bachelor's of Science and a Master's of Architecture from MIT. Now, I need to make sure I mention our sponsors for this webinar. The first one is Mitsubishi Electric. Mitsubishi Electric promotes sustainable building through the electrification of residential and commercial heating and cooling products. Their mission is to advance technologies that reduce waste output, promote sustainable resource cycles, while increasing energy efficiency and eliminating dependence on fossil fuels. Next, we have Panasonic Healthy Indoor Living Solutions. Panasonic is helping builders across the country differentiate themselves with powerful, code-compliant, and cost-effective indoor air quality solutions that provide a safer environment for homebuyers. Then we have Huber Engineered Woods. Fueled by on-the-job site analysis and building science principles, Advantech subflooring, Zip System building enclosure, and Exicor product solutions have changed the way construction teams build quiet floors and air and watertight building enclosures. Learn about their new Exicor line of magnesium oxide panels at www.huberwood.com. And finally, Schneider Electric is driving the digital transformation of modern homes with smart and sustainable energy solutions for ultimate comfort and energy efficiency. Their connected home ecosystem of smart energy management solutions provides digital control of energy use throughout a home, from the grid via their smart electrical panel to their connected wiring devices. This grid-to-plug solution makes it significantly easier to create smart solar power and backup power-ready homes, both now and in the future. Now we are going to be taking your questions today. Simply use that questions box in the GoToWebinar control panel. It's probably on the right side of your screen to send in your questions. I'm going to review those and pose them to Vivian during the Q&A time set aside after her presentation. We'll get to as many as we can in the time we have. Now, here to say a few kind words about Vivian is our friend and colleague, Sam Rashkin.
Hey, thank you, Mike. And this is one of my favorite parts of the Housing 2.0 program, the Thought Leader Series. Here's where I get to abuse a lot of my friendships and also bring some of the outstanding contributors to the new book, Housing 2.0, who just add so much insight and vision that I think reflects a lot of what we're trying to do with Housing 2.0, which is take building to the next level. Vivian's incredibly special thought leader. She's just created this whole vision that takes what was originally passive solar, and I call natural comfort, to this whole new level with environmental surfing concepts. And she brings so much experience, she brings so much compassion to this whole idea, and she makes it so it's not something you just do for nature, you do it for a better building experience. For those that recall, this is what Housing 2.0 is all about. just better building experiences. And you're in for a treat. These concepts are so important. And we seem to have forgotten just the value of nature in building design. So sit back, enjoy a lot of what Vivian has to say. She's really special. Here she goes.
Thank you, Sam. What a tribute. I hope I can live up to it. So I wanted to talk today about environmental surfing and why I picked that word and what it means. Most of you know that resiliency is the topic of the moment. Sorry, this is too fast. And most people, when they think about resiliency, think that it's about protecting buildings from climate change and natural disasters and deadly heat and water and harmful air. But really, truthfully, resiliency is about ensuring access when the power goes down to fresh air and tolerable temperatures and daylight and fresh water and food and community and mobility. So part of housing design has to be about making sure that we design buildings that ensure long-term access. And to do that, we have to fully embrace nature as an environmental conditioning strategy. And this is what I call environmental surfing. We're looking for where nature can make the difference. In a net zero economy, architecture will celebrate climate, culture, and region, balancing deep conservation with dynamic embrace of natural conditioning. If that means that deep buildings, like this one on the left, with static dark glass, such as shown on the right, must disappear. These buildings lock in a chemical soup of materials and occupant activities with serious consequences for human health, from asthma to skin and eye irritations to reproductive health to cancer. And as all of you know, this has been untenable during the pandemic as a place to go to work. Sealed and windowless work and living environments lock out the natural conditioning resources of passive solar heating, of daylighting, of natural ventilation, of passive cooling. These are nature's renewables, and they are the centerpiece of human health and environmental resiliency. So I want to introduce each of them one by one. When we design for environmental surfing, we will maximize natural conditioning for as many hours and days and months as possible. This will be unique to each climate. It will ensure that we use much less energy and water resources. It maximizes local food and materials with less transportation and toxicity, and it reduces technological complexity with just-in-time and just where needed technological innovation. So quickly, just to give you a sampling of what is a resilient building, this is a convention center on the right in Cape Town, South Africa. Many of you may know that Cape Town is a very mild and wonderful climate, a little bit like Los Angeles. And the Washington Convention Center on the upper left has since been demolished. It's a dark, deep, airless, windowless, completely artificially conditioned space. The Cape Town Convention Center is 2/3 open air. It's protected from rain, but it uses daylight, natural ventilation for all the circulation and public eating areas, and it only air conditions the lecture rooms themselves. And it's just a delight, even on a hot day, to wander from a well air-conditioned space into a naturally conditioned space with a breeze and some warmth, and then back into the next lecture room. This can be applied also on the residential scale. This project by Lake Flato Architects in north of San Antonio, between San Antonio and Austin, Texas, is about building the not so big house, or maybe what I should say, it's about building a house within a house. If you look at the stonework on the left, that is the conditioned space in this house. And when it's really cold outside, it's heated, and when it's really hot outside, it's air conditioned. But the rest of the space is designed with shade and natural ventilation. They're actually programming nature. They're making a lot of the programmatic functional space naturally conditioned only. And it turns out that even in the hot Texas climate, this is a delight. It had become a destination for workshops, for obviously vacation retreats. It is a residential home with a pool and a dorm, so you can invite a lot of friends, and then the core house itself. Really an interesting approach to zoned conditioning instead of conditioning all spaces to the same level. If we're going to do natural conditioning, we want to first design the core house for the climate that it's in. That means that if it's a very harsh climate, we're going to design it with a lot of buffer between us and the outdoors. But if it's in a very benign climate, like Hawaii, we're going to design it with a lot of outdoor living. And of course, most climates are something in between. So what we need to design is houses that expand and contract, or living spaces that expand and contract, where you basically have a core that you condition well, and you have expanding spaces that become a perfect spring space, a perfect summer, a perfect winter space with extended living. And of course, this project by Rick Joy just gives you a sense of how beautiful these expanding, contracting living spaces can be. I fundamentally believe that we should start taking every house program and breaking it into the parts that it needs to be conditioned from the parts that may not need to be conditioned. We clearly will want to, in the harshest winter or summer days, have our living room, our bedrooms, our kitchen maybe, and some level of dining condition. But there are lots of other days where we want to actually extend outdoors into the landscape. So if we can start to think a little bit about how we design houses to embrace nature, maybe not in every room, but in the majority of the rooms, we have already done a huge thing towards resiliency and low energy. So now let's be a little more specific. Most people think that the biggest challenge we have in energy is air conditioning. It is not. By far and above, the largest energy consumption in residential buildings is for heating still, followed by water heating, then lighting, then cooling. So for us to turn all of our designs around as if cooling was the dominant force is losing out on the most critical free heat that we should environmentally serve for, which is solar energy. Net zero buildings will free roll. They'll essentially, for 25 to 75% of the winter time, the energy system, the heating system will be off. And for all of you with smart thermostats, you know that the system just turns off as soon as the thermostat's temperature is met. And if it's a sunny room that the thermostat is in, it'll turn off pretty quickly during the day. And in fact, in my house, I have usually 15-minute cycles before the sun comes in which the heating system will turn on in the dead of winter. If we do deep conservation, so passive house standards and passive solar, we can pretty much meet 75% of those large heating loads that we see across America. This is for commercial buildings, but it's very similar for residential. This is what we use and when we use heating. And the system is off from early May or mid-May until early September. If we do deep conservation, if we start to go towards passive house standards, we can turn the system off all the way from the end of March till in the middle of October. And if we do that with passive solar contributions, we can get our heating down to 3 or 4 months. This is a dramatic reduction in the time in which we need to turn on the heating system. It also is a time of resiliency. If the power went off anytime between the end of March and the beginning of November, I would be fine in my house if it was designed with conservation and passive solar. If you want to look at houses that are designed around this, here's an example of a project in which the houses are super, super insulated. The windows are incredibly high performance, and it's very airtight. This is a house designed by Dennis Wedlick in upstate New York. It meets the Passive House US standard. You can see the thickness of the walls, and you can see the attention to solar energy because the glazed facade is facing south. And this house essentially uses a small percentage of what you would have in any typical house in upstate New York, but it has a much higher quality of life, and it literally is resilient. You could pretty much survive in this house with the power going out for a full year. It would get a little chilly in the winter, might get a little warm in the summer, but you would be fine. Passive solar can displace somewhere between 25 and 75% of the remaining heating demand after we do deep conservation. And of course, that percentage range depends on whether you're in a sunny climate and how cold the climate is. So if you're in a milder climate, you can meet the 75% with a lot of sun. And if you're in a harsh climate, you may only meet 25% of the load, but that is still a significant contribution. The other value of sunshine is that it turns out to be a great sterilizer. It actually improves human health. And there's studies that have been done all over the world now to look at what value do we have when sunshine actually hits the human body and hits the surfaces that we live next to. This study by Choi in Korea looked at rooms that had a lot of sunshine in them, hospital rooms with sunshine and hospital rooms that did not have sunshine, and found that there was a 40% reduction in length of stay among gynecology patients and 26% reduction in length of stay among surgery ward patients when they were in the sunny rooms. Sunshine is a cure. It has a huge emotional and physiological benefit to people. So designing around sun is really a wonderful strategy. It also is a good sales strategy. This particular library in Cambridge, Massachusetts, by Bill Ron Associates, is an example of one of the most loved public libraries in the Boston area. And it's a destination for not just college students in Boston, but for residents throughout the region because of the sunshine. It just is delightful. The second thing I want every home to do is to environmentally surf for light. It used to be that our lawn rooms would borrow light from outdoors through transoms or from adjacent corridors through smoky glass doors, and now we just basically turn on electric lights. We need to design every room to use daylight. Net zero buildings will be designed for daylighting as the dominant light source, and we will then rediscover the engineering and art of effective daylight design. The church on the left is a Baroque church in Central Europe. It has no electric lights on. It predates electric lighting, and yet for the entire day, even in a very overcast environment, through very small apertures, it has incredibly effective daylight. The church on the right is on MIT's campus. It's an Elio Saarinen project, and it is a top-lit altar that's totally a daylit altar. And the spectacular nature of that light daylight is magical. This is how much lighting we use. Truly in residential homes, we use a lot of light as well. And there's still a pretty significant amount of incandescent and compact fluorescent light bulbs in our existing homes, and hopefully no more in our new homes. Once we get lighting with more efficient light lamp sources in them, we can cut the lighting loads by at least 30%, and in many cases more than 50%. But it's when we design around daylight that we start to see dramatic reductions in the lighting energy demands. And when the buildings are narrow enough and every room has a window or a borrowed light window, all of a sudden the system can be off. You can occupy every room in your house when the power goes out during the daytime because daylight is there. It is a free energy source and it's abundant. And it also is a great sales reason. I mean, nothing is more spectacular than walking to a room where daylight washes across natural wood and gives you this incredibly engaging sense of being part of nature. Daylight can displace somewhere between 35 and 75% of today's lighting. That doesn't mean we won't have lighting. We'll come back to that. In addition to the value of a daylit space, let me close the window, 1 minute. It's the one reason I have to close windows, right? Acoustics. Well, maybe when it's a little too hot, but right now it's really nice. It turns out that daylight is critical to our sleep. A lot of the research has been going on at the Lighting Research Institute in upstate New York at RPI, has been trying to understand how important is early morning blue light and late afternoon red light, which is called circadian light, to our circadian clock and our natural production of serotonin, which is a natural hormone that makes us alert in the morning, and melatonin, which is a natural hormone that makes us sleep at night. And it turns out it's critical. We need actually the light variability that daylight alone offers us. Now we can artificially create red light in the morning and blue light in the afternoon, but if we've got daylight, why not just let daylight be our natural clock? And it turns out that for children who were put into orange glasses that cut out the circadian content of daylight in their classrooms, they had trouble falling asleep by typically somewhere between 40 minutes and an hour and a half later than their peers who were not wearing orange glasses. Just getting light into our pupils is critical for our ability to fall asleep. And again, resiliency. The airport on the left is an airport that has long since been torn down. The airport on the right is a relatively new Cesar Pelli terminal in National Airport in Washington, D.C. And you'll notice that that terminal has very little electric light on, if any. There's some required by code, but daylight is absolutely ample. And it makes for a far more beautiful space to go to wait for your airplane. After daylight, we've got to get the electric lights correct. We've got to be much more critical to light the task and not to blast light. And we need to specify lamps that have incredible efficiency. We need to get at least 80 lumens per watt or more. We need to make sure that the lamps have incredible color rendition, like 90 to 100 CRI. And we need to provide controls that are occupancy driven and daylight driven to make sure that we're not overlighting spaces that daylight is already lighting for us for free. High efficiency lighting can displace 35 to 75% of the remaining lighting demand. So design for daylight, then design for very efficient and enhancing electric light. The third environmental surfing goal is to surf for fresh air and to surf for natural cooling. Net zero buildings will have to rely on natural ventilation as the dominant ventilation strategy for every possible hour we can to enhance human health, to provide for free cooling, and to ensure that we have connection to our own communities. Because if we design our buildings sealed, we lose that connection. Now, for commercial buildings, ventilation is a relatively flat, consistent load that goes on all year round. For residential buildings, we've never had a tradition of a forced ventilation system, but as our buildings get tighter, the codes are going to mandate that we actually install ventilation systems, and the hesitancy will be to make sure that they run year round. And if we really can design to allow for natural ventilation to pick up the moderate seasons, not the very hot seasons in the summer, we would be perfectly resilient from September all the way through May. We would probably need to have a mechanical strategy in the summer because it just comes with too much heat and humidity. And matched up to ventilation is your cooling demands. And air conditioning loads in some climates will be running all year round, and in most climates it will pick up in May and go on till September. If you design with conservation, that means you're actually shading your buildings, you're insulating, you're putting in the right roofing materials for reflectivity, but we keep it sealed, we're going to be running all year round. We're just going to be using 30 to 40% less, which is good. Conservation is the first step. But if we design to turn over the management of the building to natural ventilation through a mixed mode system, this means that the mechanical system is designed to turn off when the natural system is capable of picking up the load. And for most people in the mechanical world, that could be an economizer cycle if we wanted to run it through the mechanical system. And for those of us in residential homes, it could be just opening the window on a beautiful day. If we do that with night ventilation, because night temperatures in many parts of the US are significantly cooler than daytime temperatures, we can actually get the value of free cooling, and we can reduce the need for air conditioning during the daytime. So let's start with the conservation. The very first most important thing to do is to shade. We've got to shade every window, we've got to shade our roof decks, and we've got to shade our outdoor spaces because it's getting hotter. And the sun is intense, and the hard surfaces are very absorbent, and they end up putting a lot of heat in the atmosphere. We are part of the problem for why it's 2 degrees or getting closer to 2 degrees increase in outdoor temperature. Shading can be everything from trees and vegetation to overhangs to canvas awnings. Everything you can incorporate into your designs for shading, including internal shades that are on some sort of PV automation, are absolutely invaluable to reducing our air conditioning loads and providing comfort. Sadly, at the moment, our homes are very poorly shaded, and they're becoming increasingly sealed. I see far more sealed sash windows going into residential homes with very small little operable components on the side to meet code. That's the antithesis of what we want to do. We want to have large operable components so we can live outdoors and enjoy a breeze at night. And these homes, I mean, I don't know how many tons of air conditioning we're looking at here, probably 8 tons of air conditioning. That's a sign of a not particularly cooling efficient design to have to put in that many tons of air conditioning for a residential home. And it probably isn't automatically switching from heating to cooling home, meaning that the occupant of the building doesn't even know that spring and fall happened. They literally just went from all on heating to all on cooling. This is not a resilient solution, and this is not a healthy solution for us. What we really need to do is to have mechanical systems that allow natural environmental surfing and natural conditioning. I live in a home where my dining room looks like this. I can open the entire wall of my dining room. I don't happen to have a nano wall, which is what's showing here, which is probably the most elegant, but I do have French doors from Pella, which are just, it's breathtaking to be able on a beautiful day. And every morning pretty much is beautiful in Pittsburgh. Right now it gets hot in the afternoon, but the mornings are perfect. So we open and we sit essentially as if we're sitting outside, or in some cases we just move outside. Natural ventilation can displace somewhere between 20 to 40% of the cooling load. I wouldn't need to air condition until about 10 or 11 a.m. in Pittsburgh, and then I can turn it off again at about 8 p.m. And it displaces 70% of any ventilation requirement if we start to ventilate all of our new homes. And does it matter to our health? Yes, it actually, there's a lot of research that shows that people who work and live in naturally ventilated environments have much less absenteeism. They have much fewer doctor visits. I mean, like 16% fewer doctor visits. They have a 35% reduction in hospital stays. This is a big deal. This makes a huge difference. And all of us now in the COVID time have begun to realize that natural ventilation is one of the ways, dilution is one of the ways we can reduce exposure to infectious diseases. One or two other ideas that I want to put in front of you in terms of environmental surfing that are very climate specific. For dry climates on the left is the use of night cooling and thermal mass. And for diurnal climates is the use of earth cooling. And both cool nights and cool earth are incredibly important strategies for reducing our exposure to high temperatures and low temperatures, and using nature as a natural conditioning system. With thermal mass, you essentially are taking nighttime lows, storing them in the rammed earth wall that you see here, and then during the day, that rammed earth wall will continue to absorb heat from the atmosphere or from you and make you feel comfortable. It's a radiant cooling source that's incredibly comfortable. And on the right, a Malcolm Wells project in Massachusetts, you're looking at a project that is nested into the earth, and the earth is burned up around in order to provide free cooling. Everyone knows when you go down in the basement in the summer that how much cooler it is in the basement, even without an air conditioning system. That is the power of earth cooling. Windows matter. Really, anybody in the passive house community knows that the first thing you do is specify the windows. They have the longest lead time, and they're the most critical decision you make. You want the highest R value you can afford. You want to make sure the windows are designed to connect you to outdoor rooms. I love tilt-turn windows because a tilt-turn window, which is what's shown in the Marvin tilt-turns in the picture here, I can tilt it as a hopper at night for natural cooling without drafts, or I can use it as a casement and have a lot, and almost feel like I'm sitting outdoors and have a lot of ventilation during the day. So tilt-turn windows are no longer, to my mind, a luxury, but a standard for resilient design and for natural conditioning. I want high solar transmission glass. I have a continued ongoing debate with the EPA folks who keep putting out standards for anything but northern climates to go to low solar transmission. I would argue that even in Texas, you're going to want that sun in January, February, December, January, and February. So I want high solar transmission on the south. I do want low solar transmission on the east and west because those are very problematic and summer intensive suns. And I certainly want high visible transmission. I want people to see the colors of spring and fall. And then I want everyone to get involved in dynamic, not necessarily only static. So on the bottom right are sliding shutters that allow air to come through, and they're dynamic. So you would slide them over the windows in the summer. And on the right upper photo is a relatively affordable exterior shade that's just gravity assisted. You just, it could be either mechanically raised and lowered, or you could have an electronic button, but that allows you to shade the outdoor spaces when the sun angles get low and live outdoors for longer periods of time. The outdoor room is incredibly critical to our sense of place and empowerment. Once we design for natural ventilation and natural cooling, we start to see buildings with lots of operable windows, not just a few little trickle vent windows, but lots of operable. This school in Germany easily can cope with COVID as a challenge by having a lot of fresh air flowing through the classroom. This shopping mall in Milan, the Galleria, one of the most famous shopping malls, unlike the one on the left in Denver, which has long been torn down, the Galleria is now, I forget, in its 5th century, is a outdoor fresh air in a hot climate shopping experience, right? We do not need to air condition every space. We can enjoy the breezes and the natural shade of architecture. This is where we are in commercial offices. It's very similar for commercial homes or residential homes in the US. We're using a lot of energy. We use it to heat, to cool, to light, to ventilate. This is our conditioning energy. I'll come back to plugs in a minute. And this is where we could be if we just did environmental surfing, deep conservation, passive conditioning, or environmental surfing for heat, light, air, natural connections. We can bring it down to this level. And now, if I go from here to here, now I can meet that with photovoltaics. Now I can do solar thermal for hot water and solar PV for electricity and meet the loads of this house by Doug Farr in Chicago. It is a net zero house that can be met by the renewables on the roof. So we can environmentally surf for electricity. In most cases, we do connect to the grid. We don't battery store it in the house itself. So we use the grid as our backup, but we're essentially achieving net zero. And the more the residential community can achieve net zero, the residential community is 20% of the total US carbon problem. And if we could get our new construction to net zero, we could easily get down to 10% of the US carbon. We could take 10% out of the equation through residential investment alone. But wait, I need to talk about the plug loads, because this house here can be net zero unless people start to put a lot of energy intensive technologies inside. So we've got to pick our technologies and our control systems to be low energy, to be able to be supported by a small generator backup. So we have a core plan for when the power goes out after a major hurricane, we can run all of our core services and to know exactly what those are. And they're typically going to be your refrigerators. They may be your cooking. They may be communication. So we're literally starting to look at what's our core and how efficient can we go. We absolutely need to specify Energy Star for all appliances. We need to have a handle on plug loads, and we need to embrace innovative control. I noticed several of the sponsors today are Mitsubishi and Panasonic, and it's really important to actually look at zone control. And one of the advantages of split heat pumps is that every heat pump unit could be individually controlled. I don't have to cool my bedroom if I'm not in my bedroom 24 hours. I'm just going to cool it an hour before I go to bed and into the early morning when the temperatures outdoors have gotten to be mild. And I can actually control it as if it was environmentally surfing. It was meeting the moments when nature could not meet those moments. So I think it's time for us to really embrace innovative control over what is called the Internet of Things. Since every one of these items has a digital address now, I can make decisions about when I'm going to use the washer dryer or when I'm going to turn on the air conditioner in a specific zone. I want to end with a few other things that we can environmentally surf for besides heat, light, air, cools, and power. We can environmentally surf for water. Residential homes have the potential to eliminate the use of potable water for landscape. But to do that, we have to actually capture site water and roof water and store it for landscape. And we have to design landscapes that use much less water, that are indigenous to the region they're in. So if you as a building owner, designer, and developer start to think about, well, I'm going to collect all the water on the hard surfaces on the site and on the roofs and find a way to store it. And then I'm going to trickle feed all the landscape and choose landscape that has very low water demands in that region. I can actually eliminate 50% of the water demand in America's homes, which is used for landscape irrigation, at least in Denver, as an example. And we can also regenerate our water supplies, because what we're doing is we're infiltrating the rain back into the aquifer, the natural aquifer, rather than running it off into some storm sewer and having to take it back to be processed in a water processing system. Rainwater regeneration can displace somewhere between 20 to 60% of today's processed water. We still need potable processed water for drinking and for cooking, but we don't need it actually for a lot of other things. We can use gray water and or rainwater for a lot of things that we're using processed or potable water for. And it does make actually for far more beautiful side yards and far more beautiful sidewalks. Both of these examples on the right by Herbert Dreisaitl is a side yard that's all about stormwater management. And in a peak rain, it becomes a play zone for children that is just delightful. And the one on the left is sidewalks in Portland, where every sidewalk is treated as a reservoir. So there's huge catchment potential so that the water can run off the streets through those little connectors. And whenever I see concrete around a tree and there's no break in the concrete, I know it's not designed as a reservoir. You have to break the concrete the way it is here for the water to flow into those reservoirs. And then the reservoirs are very deep, and the landscape is selected to be able to cope with the ebb and flow of water. There are entire neighborhoods designed around water. This one, Dockside Green in Victoria, Canada, is the most beautiful residential neighborhood I've ever visited, where all of the rainwater and all the gray water, and on site, they have actually put in a site sewer system that serves an entire region. They were able to get their housing development redistricted as a sewage destination and get the city to invest in all of the water infrastructure for this project because they manage sewer for a much larger catchment area. So they do gray water, rainwater, gray water, and black water management in a beautiful articulated set of canals that are directly adjacent to people's terraces in Victoria, Canada. It's a community that realized by becoming the water and sewer authority and a waste heating authority. That's how they paid for the quality of physical space. Then we can environmentally serve for food. We can design food resilient homes where people can actually grow food, at least in the summer, and store it. So we design for storage. We can make food part of the actual landscape of choice, and easy to grow vegetables and quality of experience for you in a residential home. I've had a master's student do an analysis of how much food we can grow in an acre or half an acre. And in this case, it turns out on the Brooklyn Grange roof in Queens, on less than an acre, they're able to grow 7 tons of food. And we were able to quantify that. Here's an entire community in southern France designed, residential homes designed around both work and food production. It's a utopia community called Arc et Sinon. It was originally planned to be a whole circle, and it's 2 centuries old, but it's an amazing idea about how food can be integrated to housing. And then the last is environmental surfing for mobility. Even mobility can be surfed, it can be preserved, it can be cascaded. You can make walkable whole life communities filled with a diversity of culture, ages, and professions, and then still give provisions for transit and for vehicles. If we design for walking, we can displace somewhere between 25 and 75% of our car trips. There's an incredible story about the state of Pennsylvania that there are 7 parking spaces for every car in Pennsylvania. And if you think about that, why would there be 7 parking spaces? It's because that's how many spaces we need in our typical week to park our car just to get through our weekly needs. A space at school, a space at the library, a space at church, a space at the shopping mall, a space at the exercise in a recreational center. We're literally replicating, and all of that pavement is causing huge heat island effect and storm runoff effect. So if we start to design for walking, we can displace a significant percentage of the car trips. This particular neighborhood called Vauban in southern Germany is designed for walking. They actually became the transportation authority. There is a light rail that goes to the community. You're allowed to bring your car to unload, but you can't leave your car. You have to take it to a structured garage, and the streets belong to the kids. and to the people who live on those streets. And it's just a spectacular neighborhood. This is what the light rail looks like. I always love to see light rail floating on grass because it sort of implies that this is about providing nature. You'll notice there's a huge dip in the grass. That's about water storage. That's to make sure we have the ability to absorb huge rains, and not at the tracks, but adjacent to the tracks, so the tracks can continue to perform. You'll notice there are sliding shutters on these housing because that's what we need to do to protect against, and they're porous so the wind can continue to go through. If we environmentally serve for mobility, which means we're really designing for walkability, we bundle that with a not so big house, we can sort of environmentally serve for community. I think a lot of people began to realize during the pandemic how valuable it was to be near someone else where people could sit on their porches and actually carry on a conversation with 6 feet of distance, or actually, do a concert across a project that was filled with multifamily housing. I mean, all of this is about community. And co-housing and tiny houses and pocket communities and the not so big house, these are all incredibly valuable ways to environmentally serve for energy, for heat, for light, for air, for food, and for mobility, and lastly, for community. Resilient communities are just wonderful places to live. And I think that the design masters of environmental surfing will preserve, cascade, and regenerate nature's abundant resources for sheer delight. They'll create technologies that mimic nature and regenerate without waste, displacing design that cuts us off from the environment, and that architecture that's produced by environmental surfing will celebrate the time of day, the seasons, and the culture that is unique to each community and to nature's creative energies, and that is central to a resilient future. Thank you. Should I leave the last slide up? I'm happy to take questions, and I probably talk too fast.
No, it's okay. Let me get back on here and let people know that they can go ahead and ask their questions now. Just send them in via the questions box, and I'm going to put that message out there to everyone. Just like that. All right. We do have some questions to get to, Vivian. And so the first one is from Judith. She wants to know, are there good examples where these principles are applied to low income and affordable housing?
That's a really, really good question. I would suggest you go to the AIA Committee on the Environment Top 10 Awards, the AIA COAT Top 10, and type in affordable housing. What has impressed me is the number of affordable housing projects, many of them in California and state of Washington and Texas, that have managed to do incredibly energy efficient and environmentally sort of surfing projects that are affordable. And a lot of it has to do with creating community and privacy, because one of the challenges in affordable housing is that people need a place to get away from and not be seen, but they also desperately need a sense of community. And so they really have been designing. I didn't put in a picture of some of the tiny house projects that you can see that are dealing with homeless populations, and a few regions have established legislation that allow people to put tiny houses behind their house as a way in which to provide housing for homeless. And I've seen some amazing videos of, I think, either Portland or Seattle residents who've agreed to put in a tiny house for a homeless person in their relatively deep backyard and made lifelong friends, just people that have really enhanced their quality of life. And they did it for, obviously, for commitment to humanity and a desire for their kids to understand diversity and understand both economic and ethnic diversity.
We, I had a question for you as well. Is it, when early on you were talking about solar gain and being able to heat and bring in light, Is it difficult to meet certain energy code requirements with so much glazing?
Okay, let me just go back to here, this house. Let's just take the Enel house by Doug Farr. As you can see, there's quite a bit of southern glazing here. And it's a combination of a desire to allow for a lot of airflow through the space, but also to catch a lot of sunlight. This is Chicago. You probably would not see glazing of this quantity in Phoenix or in a lot of warmer climates. So this is something when you're dealing with a cold climate and you're trying to meet the load through passive solar heating, you're going to see quite a bit of glazing. Most of the glazing has been corralled to the south, not all of it, because you do want cross ventilation. Sometimes, of course, you have beautiful views to the east or the west, so there's always a challenge there. But given the insulation in the remaining walls, I think they would not have to, I would gather, I'm sure he met code in Chicago, I would gather you can easily meet the energy codes through high efficiency roofs and walls and floors.
Hey, Vivian,
yeah, go, Sam.
I'm going to chime in because I love your feedback on a question I have. On this design, I have an issue because I always consider butterfly roofs a design defect. Roofs are designed to shed water, not supposed to collect water. Am I wrong, or is this, or how do you see this? Because I always struggle when I see designs with butterfly roofs. You first and foremost, a roof has to shed water. That's its purpose.
Yeah, I would suggest that a flat roof is your most dangerous roof. Your butterfly roofs, especially with leaf buildup and other things and snow buildup, you could end up having some serious concerns. This clearly is designed to catch water. They actually are trying to do on-site water catchment to be able to store on-site for landscape irrigation, right? So, but you have to keep it clear, and that is an issue. You cannot, you can't be lax in your guttering. And the guttering would be oversized and very well detailed. I wish I could have Doug on the line to answer this question about what detailing he put in there. You'll notice, by the way, also there are rooftop ventilators in there, and those are ways in which to induce airflow. You see those little spinners there. There's two of them on both roofs. Those are the kinds of spinners you see on a lot of barns throughout the Midwest and Pennsylvania and other states. And they basically, doesn't matter which way the wind's blowing, they start to spin and they pull suction. So they actually induce airflow. Now you'd want to cut them off in the winter because you don't want to induce airflow in the winter. But as soon as it gets to be warm, you would essentially open the damper on those ventilators and it'll pull air right through your space, and you just enjoy a natural breeze, even if you're in a high density urban environment like this one. But in answer to your question about water, you've got to do a very good detailing job because you're going to catch water and it's going to get cluttered and you're going to have to keep it clear.
Yeah, answers my question. I'm a low risk guy, so I probably will stay with a shed design. Too long a period where snow could sit, melt, freeze. I'm kind of low risk.
Now you'll notice here the overhangs are designed to shade the facade. We appears to be looking at a summer photograph. You'll notice that the entire glazed area is in a natural shade. Now that's probably because it's noon and the sun is pretty high in the sky. As it swings around, it starts to come at you on an angle. And so you need secondary solutions, which is why I like dynamic awnings myself as a way of guaranteeing that I get shade late in the afternoon.
I'm glad you raised that point too, because what I like is when you have a whole wall of windows, that there's an intermediate level trellis or something that lets light through and blocks it in the summer. So I find that's a good solution because it looks great, but you just need that intermediate level.
Yeah, and actually, landscape materials, if you do grape trellises, are amazing in terms of what they're able to shade. I mean, you see them, of course, throughout the Mediterranean, but we don't understand that we can actually grow grapes that will shade our entire glazed facade, and they'll go away in the winter.
You know, we were talking about water earlier, and we actually had a question come in from Robert. he was referencing the Vancouver housing project that you were showing, and he asked if water retention outside units create an untenable mosquito problem, because he's saying, that would prohibit me from going outside during typical mosquito seasons. So can you talk a little bit about that?
Yeah, I had the chance to go and visit Dockside Green, which is why I have photographs of it. It has actually a pretty substantial fish population, and it is actually a fishing destination for a lot of residents. It's right adjacent to a bike path that goes all the way into downtown Vancouver. It's about a half a mile or 3/4 of a mile from downtown. You'll notice there are also ducks in here. It is considered an entire biome. It's really designed to keep the mosquito population down by having fish, which are very effective at keeping mosquito levels down. I do not know if they have to do this is gray water that's been processed. It could have been black water that was processed and then turned into creek water. And it's a continuous body that is flowing. It's not stagnant.
Gotcha. Okay. Sam was just on here, and he may pop back in when I ask this question. We've talked in the Housing 2.0 workshops about solar production, and Sam's more a fan of it being on the roofs of like porches as opposed to the roofs of the structures. My question to you, Vivian, was you had earlier talked about shading and how important shading is. But does shading in some ways conflict with solar energy production?
So, first place, you could use photovoltaic as a shading device for windows, but have it exposed to the sunshine for solar electric, right? So I can use a PV panel as a shading device. I can do canopies. I don't have a picture here, but I can do canopies over driveways that will shade the driveway or shade the carport and collect energy. So one side of the PV panel is for collecting a lot of energy for electricity, and the other side is for shading and for rain protection. So I think in that regard, PV works extremely well as a shading device and as a solar capture device. Where we get into trouble is when people overshade their windows. If the window is pulled too far away that even low sun angles don't get into the house, then we lose the advantage of passive solar heating. So we need to, and there is a sort of a sweet spot, and it's very climate specific, both latitude specific. So the depth of the overhang for a latitude like Victoria in Canada would be very different than the depth of overhang you would need for Pittsburgh or for Florida. And the length of the cooling season is very different in these places. So you have to get exactly the right length of permanent overhang. And again, I love awnings. You see in Germany, awnings, canvas awnings everywhere, very lightweight, very easy. Many cases they're mechanized so that they will roll up and when the wind picks up. And they're very affordable. You can buy them at the local hardware store, and yet you can't hear. Here it's still quite an ordeal to get shading devices, rolling external awnings purchased, installed, and electrified. But there it's become a norm.
So Vivian, just to clarify Mike's comment, I always remain concerned about solar mounted on roofs for a number of reasons. You're introducing like 30 roof penetrations through the primary purpose of the roof is to keep weather out, and now you're puncturing it through all the mounting rack. Then when I have to replace a roof, I've now put onto that homeowner the burden of having to pull the solar system at maybe another $3,000 or $4,000 in order to replace the roof. And then on top of that, the performance of the panels next to the roof is reduced because of all the heat buildup behind the panels. So if I do the solar on a porch as the finish over the framing, I get rid of the sheathing, the underlayment, the roofing. I just have more daylight coming through to the lower level below the porch than I would with a solid porch roof cover. And when it's time to replace a roof, it's bifurcated from that whole operation. It's just the porch roof. So that's what he's talking about that I advocate. And I'm a big believer that communities should have front porches to provide community connection. Back porches, I think, are great to provide exterior property additional use capability, because you can sit under the sun or the weather or whatever may be going on. Notwithstanding, you're balancing all these other needs that you speak to about capturing daylight, capturing solar heating. So all these are a bunch of priorities to catch, but that's what he's referring to. I tend to look at huge savings to do the solar integrated, particularly great if it's a freestanding structure, maybe as you're suggesting, a carport or a freestanding pavilion for enjoying the property. But that's where that was coming from.
Yeah, and I actually think it depends a little bit on the audience, but you know, if you are designing freestanding pavilion spaces, you know, or if there's an in-ground pool and you're doing a cabana, I mean, there's just a lot of functional programmatic space that could easily have a PV roof. That wouldn't necessarily mean that your main house needs to be the photovoltaic array. I do think that the PV is changing pretty rapidly. And I think even ownership of the PV is changing about to what extent we might expect the utilities to be the primary owners of the roof, because it's to their advantage to own the technology and essentially share the cost benefits with the customer. So I feel like we're in a state of change in the photovoltaic array part of this equation. I really want to emphasize conservation and passive conditioning as the most important message.
That's great.
I think, yeah.
And I don't think that's a bad thing, what you're suggesting. I think PV will become less income regressive under utility ownership, then everyone would get it. Right now, I think it's really skewed to very high income households. You'll see it on homes. And so it's maybe not such a bad idea.
Yeah, I think we're going to start to see glazeless solar systems, you know, where metal panel roofs are able to capture heat through innovative layers. There's a lot of innovation that's occurring in the certainly the heat, if not the power side of the equation. And just a couple of overriding messages. If we can start to design the house within a house, start to strategically think about what spaces actually need to be air conditioned and or heated for long periods of time, simply because that will make life enjoyable and safe, versus how many spaces can we slowly peel off and locate in the most benign climate location to extend our living space whenever the temperature is mild, including outdoor rooms as part of that. And I think if we can start to rethink the way in which we design our programmatic spaces, and we could dramatically reduce the load and provide much greater comfort. So you have an inner zone that's super comfortable when it's really hot outside or really cold outside, and then you have all these special zones, some on the south that are perfect in a cool sunny day, and some on the west that are perfect in a breezy, overcast summer day. I mean, you literally understand that we extend our living with the seasons, as we once did with the front porch and the sunroom. We once used to migrate based on the time of day or the season.
And to your point, from a more business motive lens, the conditioned space is going to cost me retail somewhere about $250 a square feet, and the outdoor space is going to cost me somewhere about $75 a square foot. And yet the user enjoyment of the outdoor space may be even greater than the conditioned space. So there's some huge, again, user experience opportunities if we leverage more space, like you say, on the exterior of the house. So.
We've got a couple more questions, and then we're at the top of the hour, Vivian. Go ahead.
Okay.
You mean Vivian and I can't just talk? We have to answer questions.
No, it's all good, and I think a lot of people are enjoying the conversation, but I wanted to make sure we got to some of the questions, because our audience is always good for more questions. We had a couple of questions on the topic of natural ventilation. So the first one was from Elizabeth. Does natural ventilation work in high humidity areas?
Absolutely. In fact, traditional housing in high humidity areas only use natural ventilation, but they did always stack ventilation assist. And if you look at, Charleston, South Carolina, all the traditional architecture in Charleston is designed, but it predates air conditioning. It's designed to maximize airflow through the spaces. And it included having rooms that were just, beds that could roll out onto a sleeping porch, and the sleeping porch was completely screened in. And the screening material has gotten so elegant these days. You can create a screen porch that almost feels like you're seeing right through it. And the ability to create that sort of a screen porch extension means that, you come home from work, you can sit on a screen porch, and the breezes from all directions just go straight across the space. It's just, and you're sitting in nature, you're sitting with the trees, which is just fantastic. So I absolutely believe that it can be done with humid environments. Now, can I run air conditioning while I'm letting a lot of humid air through? No, because the air conditioning will condense on all the surfaces if you let humidity into the occupied space. So this gets at the question of a room within a room or a house within a house. If I need to have some of the spaces just be sealed and air conditioned, I'm not going to naturally ventilate them while my air conditioning is running, unless I have a dry air system. If my breathing air system is a desiccant air and I dry the air, I could probably run cooling to a moderate temperature. But if you ran air conditioning while you've got the windows open, you will get condensation on surfaces, which is not what you want.
Or even, Vivian, you develop a strategy where you don't use natural ventilation for the core worst, most humid months, let's say in Charleston, but you're still able to use natural ventilation for 2 months on the front and back end or longer. So you're still getting a third of the year or 40% of the year where you can rely on natural ventilation.
Yeah, I'm always amazed that people move south because it's such a benign climate and then build a sealed box and air condition it and or heat it all year round. I mean, it's like, why did you move south for a benign climate if you're not going to enjoy the 6 to 8 months? Actually, it's interesting. When I started doing studies of climate data, we categorized all the US weather stations, and the most perfect climate is where the National Weather Service is hosted, which is in Asheville, North Carolina. It has the perfect short winter, the perfect short summer. It's hot and humid, but short. It's cold and snowy, but short. And it has these incredibly long spring and fall. So if you move to Charleston, you want to live outdoors. You might want screening material. You might want your outdoor porch to be screened because there are mosquitoes in Asheville. But it's about enjoying the climate that you're in and knowing that when it's benign, it's fabulous. And it's a lot of hours.
Let me ask another question on natural ventilation. You talk about, oh, okay, they moved south, they closed themselves in. What about people with seasonal allergies?
Yeah, that's a good question. I don't have a good answer to that. I think, I mean, allergies certainly. Do people with seasonal allergies spend time outdoors hiking and playing ball? Probably. I think probably the most concerning thing for people with seasonal allergies is not to have allergies at night when you're trying to sleep. So I think I would design my core house to not only filter out any pollen and concerning, but also cool and dry, to try to help people when they're in the core house, because the seasonal allergies are driving them crazy. I don't have a good answer to that. It's not easy. I do know that there are also people with chemical sensitivity, and the way in which we're designing houses as very tight, sealed, with no actually mechanical ventilation system, and then people bring in all kinds of room deodorizers and plastics and materials that outgas, and I'm thinking to myself, boy, we've just created a thermos bottle of chemical soup, and we need to be very aware that natural ventilation is one of our safest ways to remain healthy. And I think the pandemic has made that clear. I mean, there's so much less contagion when we're outdoors. than when we're indoors. So we should design to let spaces be outdoors.
We had a question from Judith. She wanted to know what you think about the push for high density housing as the way to address housing scarcity.
I'm not sure I have an answer on the top of my head. I mean, clearly we need to, in some areas, we need to increase density in order to be able to provide adequate housing. America is not Hong Kong. We do not have land use densities. There are some cities where it's critical to increase density because the city is already built up. But there are a lot of cities where we have so much vacant property and we have so much land that's just dedicated to surface parking and excessive roadway widths. And I mean, we've got space. I'm more of the belief that we should build according to Haussmann's rules for Paris, which is 7-story walk-ups. And thinner buildings, so that, you know, with courtyards, so that every room is daylit and naturally ventilated. I mean, Haussmann, of course, Paris predates air conditioning, and had to figure out a way to ensure survival, and it predates the elevator, so 7 stories was sort of the limit of what you can carry groceries up. So I think if I was gonna, you know, be king for a day, I would probably say let's work on the notion of 7-story max with a thin enough section or courtyard design to guarantee daylight, natural ventilation, and then I would orient it to understand that the south is the easiest orientation for sunshine, and east and west is the most problematic.
Okay. Going to verbally put out our final call for questions. The last one I've got right now is from Hal, and he wants to know, how come trom walls have essentially disappeared?
I still teach trom walls. I actually think for certain climates, and if you have a lot of glass and you don't need the windows and the direct access to an outdoor space, they're an ideal way to collect and store energy. They work best in climates that are sunny, because you're trying to charge somewhere between 8 and 12 inches of solid thermal mass. So you need sunshine to actually penetrate that much, just a lot of weight in a building. And water walls are a little bit quicker because they convect, they circulate. But so I still fundamentally believe that trom walls make sense. For me, they're the additional wall surface that we didn't need for access to the outdoors. It's going to be in the sun anyway. Why not find a way to collect and store the energy and then just let it slowly, you know, give back to the spaces that it's adjacent to. By and large, it's best when it's a radiant exchange at night, just giving me free heat. I still think trom walls and water walls are very valuable solutions, and they're passive.
All right. True. All right, well, I don't see any other questions, so I want to extend my heartfelt gratitude to Vivian for sharing your time with us today and your knowledge. We really do appreciate it. Sam, thanks for the assist today. Always good to see you. And thank you to our audience for attending and asking great questions. And of course, our sponsors, Mitsubishi Electric, Panasonic Healthy Indoor Living Solutions, Huber Engineered Woods, and Schneider Electric for their generous sponsorship of this webinar. Now, Sam, don't go away yet, because I want to make sure that people know that if they like what they heard today, this is exactly the kind of insight and knowledge you can expect in the Housing 2.0 program led by our friend right down there, Sam Rashkin. You're thinking, it's probably too late to sign up. It is not. No, in fact, we're going to be starting the Q3 workshop series next Thursday, September 2nd. That's just next week. So you still have time to sign up. We still have spots open. And for more information and to register, please go to www.greenbuildermedia.com/housing-2.0. And there's actually a link in the chat right now. Sam, any comments on Housing 2.0 before we end up today?
You're on mute,
Oh, hold
Sam.
on. Yep, that's all right. Take two.
Okay, I just want to also mention the next action group where we actually apply best practices will be starting later in September. And that's also looking for a few more good special builders who want to take their design and extract all these cost savings, added value. Also, the book will be coming out in 6 to 8 weeks, depending on printing time, and to look for Vivian's great whole essay on environmental surfing in chapter 5 in that book, and get a great kind of run down some more her important concepts. So look for that as well. But yes, please join us for the workshops. They are a great way to kind of to just experience the 150 best practices we advocate for just doing beyond even design, communities, quality, sales, performance. So love to have you.
Now we're going to be taking a little break from our webinars as we get ready to ramp up the Q3 workshop series and, as Sam mentioned, another Housing 2.0 action group. But never fear, we'll be back with more webinars for you in the weeks ahead. Until then, have a great Labor Day weekend. Stay safe, stay cool, and take care.